You are welcome back to my YouTube channel. I remain my humble self, Edu Hader. My YouTube channel, Mathematics with Edu Hader. Please don't forget to subscribe, like, make your comments, and share. Thank you very much. Now, today we are going to differential calculus, and under this we're talking about function on function. And function on function is one of the techniques, is one of the ways, one of the tools with which you differentiate problems or functions that are of this nature. That is, if you have, for example, you have your y, of course, your y is your f of x, which you know, right? Now, if you have f of x, and there's another function in f of x, so we say call it function of function. It means there are two functions, either by products or by quotients. There will be more than one function in a function. So what you will use is you derive another function out of this function. If this function is complex, so you, of course, the y prime is your f prime of x. So if this function is complex, you derive another function out of it, such that it will make it easier for you to solve. Let's check these examples. 1. You have 3y is equals to 3x squared plus 5x raised to the power 4. Now, I'll take you two ways to go about this. There's an easier, faster way, and there's a general way, which follows chain rule. Yeah. So if you have chain rule, of course, you have your the y, the x can be equal to du, okay, dy du times du dx. You don't need to cram this. Yeah. Dy dx will be equal to dy. First start with this. You brought in another function. You brought a function out of this function. I'll call it u. So we differentiate that with respect to u. Since this is equal to this, so you have the y du times du dx. This multiplication. This is what I mean. Look at this. So since it's going to be very hard for us to differentiate this function. There's a function here, and it has a power here. So it's like we have two functions, a function in a function. So we can just say let u be equal to 3x squared plus 5x. It makes the work easier for us. You get? So here now, since u is equal to this, you cannot have y to be equal to u raised to the power 4. So you have u to be equal to this, y is equal to this, so you can differentiate u with respect to x. What I explained under solving by rate of change. You use chain rule when you are using rate of change. So this is the same principle. So u is equal to this, then you can now say, oh, differentiate this with respect to x, right? So you have the u, the x. To differentiate this, you have 6x plus 5. Then dy du. With respect to u, you have 4u, reduce this by 1, it's power 3. Then here you are good to go now. You can now find the product of these two to get the derivative of this main function. You get? So you now have the y, the x will now be equals, I've written it, dy du times du dx. So dy du is 4u. This can come first, they are commutative, any of them. So you have 6x plus 5 times 4u raised to the power 3. Don't forget, instead of writing it in terms of u, recall u was equal to 3x squared plus 5x, right? So the y, the x, can now be equal to 6x plus 5. Close this bracket, and you have 4 times, you have 3 x squared plus 5x. Then what? Raised to power of 3. So this is just coming, can bring out the 4. You have 6x plus 5. Then you have 3x squared plus 5x raised to power 3. You're as good as done. Now there's a simpler and faster approach. Once you are here, the one inside, we call it the core function. Yes. There's a simpler and faster approach. You can just say your dy dx is this. Bring the power down. Have 4. Open the brackets. The power involved, you brought it down, right? Good. Now differentiate the core. What is inside? If you differentiate this, you're going to be having 6x plus 5. Close the brackets. You see that? Brought down the power, this. Differentiate the core which is inside this. Now, you now reduce. Normally when you differentiate, you have to reduce the power, right? So now pick everything now. All the whole function. Pick it, then reduce the power by 1. So that will just be 3x squared plus 5x raised to power 3. You get the same from here all the way from here using chain rule or function of function. You get, then there's a simpler, faster approach, which is this. Use it for any combined function. You will get the same answer. Question 2. It says x cubed plus 2x plus 5 all raised to power 1 upon 3. You get it? So here, what do we have? Solving. Now, solution 2. Sine x. There are two functions here. It's glaringly, in fact, this is like 3 functions in one. In a question. So you have a function of the function, you have another function as a product of it. Again, you get? So we can say using our product rule. I taught product rule technique in one of my videos. So check my videos on my channel, you will see that. So here, this, let's take this as u. Let's take this as v. Right away. They're using product rule. Product rule says the y, the x can be equals to v du dx plus u dv dx. Please, this is v, this is u. U v du dx plus u dv dx. That means when you are differentiating this, you owe this, you differentiate this, plus you alternate that. You get? So let's go now. Since we have all our parameters here. So that will be equal to what about v sine x? But wait, there's always a better because of people coming up. Find your dv, du, dx first. So du, dx, find everything, be prepared with that. Du, dv, differentiate this. These are you, right? Let's use our second approach. It's easier, right? So bring this down. 1 upon 3. Differentiate this. You have 3x squared plus 2. If you differentiate the constant, you have 0. Good. Then bring the whole function. The whole function is x cubed plus 2x plus 5. Reduce it by 1. If you reduce 1 over 3 by 1, what do you have? Let's do it together. 1 over 3 minus 1 over 1. You have 3. Then you have 1 minus, that's minus 2 upon 3. Isn't it? So, now, our dv dx. Differentiating v with respect to x. We differentiate sine x. I also talked about teaching differentiating different functions in one of my videos. How you can easily differentiate your cos, your tan, your cosec, your sec. How you can derive them from each other. Go check the video. So sine x will give you cos x. Meanwhile, cos x will give you minus sine x. Derivation. So you add this, Done. Now you can now go and use the rule. So dy dx can now be equal to what? V. My v is sine x du. When you differentiate this, du is this as 1 over 3, open the bracket, 3x squared plus 2, close this bracket, open this bracket, x cubed plus 2x plus 5 raised to the power minus 2 over 3, then plus u is this, x cubed plus 2x plus 5, all raised to the power 1 over 3, u dv, and you have cos x. So it's left to you now to now look at it. Can I factorize? Is something common? This guy and this guy, they are common, but they have different powers. You can work around that, isn't it? So let's factorize it. Let's factorize this. So dy dx, there's no space here. Let me use this space. Dy dx can be equal to let's have x cubed plus 2x plus 5 all raised to power of 1 over 3. Then open a bracket. Okay, let's do this. Then you have 1 over 3, open a bracket, 3x squared plus 2. You see this? So you have raised to the power minus 2 over 3, right? So what will you add to this? That will give us 1 over 3, okay, I'm coming 1 over 3 plus x over 1 will give us minus 2 over 3. Yes, you can easily get it this way. Automatically your x can become minus 2 over 3 minus 1 over 3, and that is minus 1. Do you understand here? So you put minus 1 here. Then here you have plus, you can just write, yes, this and this just have cos x. So this is our dy dx. So you have this. Is that understood? So you have gotten what that is about. Simplified form. Thank you. Question 3. I guess you can try question 3. Or let me check my time. Okay, let's solve it. Solution 3. You have 3 exponential 2x cos 4x. So y is equal to this is a function. So the y, the x. Of course, this also what? We have 2 functions. So take this to be u, take this to be v. You get? So you take this to be u, this to be v. Should I leave you with it? Okay, good. Let me explain something because of cos 4x. So you have du dx, which is, of course, if you differentiate this, you have 3 times, this comes down. You are differentiating an exponential function, you differentiate the core, so you have times 2, then exponential of 2x. Y dv, we have gone twice, but because 3 is a constant, that's all. So you have this, the 4x, 4x2, you pick it that I explained the other one. What's the core here? The core. Now, there are 2 ways you can go about this. Okay, let me go. The v can be, you can say, let me call this cos 4x. You also say, if you use chain rule now. So let's, instead of cos 4x, because cos something, there are 2 functions. So let 4x be equals to u. So now you can say du will now be equals to 4, right? The u will be 4, then cos u, the y will now be equals to what? Minus sine u. Instead of cos 4x, now be cos u, right? So now the y du will sine u, the u dx will be 4. So multiply both of them together. So the y dx will now be equals to what? Minus 4 sine u, which is equal to minus 4 sine, what is u? U is 4x, sine 4x. You get? Alternatively, you can just do it this way. Look at the function. We are looking for the v, right? So we've gotten our du to be this dv. Can easily say this is dv. Dv will now be equal to this. So you can say alternatively dv can be pick the core, which is 4x. Differentiate 4, x, you have 4. Then you pick everything together. Differentiate cos itself. Cos is what? Minus sine, include this 4x. If it is having any power, you reduce the power. You get? So that's why you are going to be having minus 4 sine 4x, which is the same thing with this. They are the same thing. So if you go by a chain rule, go by the shorter method, you get the same answer. Now, the y dx will now be equal to 1v cos 4x times the u, which is this, times 6 exponential 2x plus v, I use v du, so this will be u dv plus u, our u is 3 exponential of 2x, the v is minus this. You have minus 4 sine 4x. So that can be equals to what? Cos 4x, 6 exponential of 2x, minus this times this, you have 12 exponential of 2x sine 4x. Something is common. So that can be equal to what? Can do it 6 exponential of 2x, open a bracket, cos 4x minus 2 sine 4x. So you can, assuming this 2 is not there, it would have been easier. You say cos a, take this as a cos a minus sine a, there's an identity for that. So you can actually stop here. Thank you for staying with me. Please don't forget to like when you watch the video. Give me a thumbs up, man. Then when you make a comment, I will reply, and also share with friends. Do not forget to subscribe. Thank you very much.